My name is Sahil Ramani, and I'm a machine learning engineer at Zoox. Um, a few housekeeping notes before we begin. Please silence your cell phones during the duration of this talk. And also, please fill out the speaker survey at the end of the talk. This helps us understand the relevance of this content a little better. So yeah, that would be really helpful. All right, so yeah, where were we? So machine learning for games. Specifically, let's focus on machine learning in terms of the human aspect. Like this talk is about you and how we can navigate this unprecedented future together. But before we do that, let me introduce myself. Again, my name is Sahil Ramani, and I work at this company called Zoox. Zoox makes autonomous vehicles, and as we'll see today, there's a lot of strong parallels between machine learning for self-driving cars and machine learning for games. A little background on me. I have over 9 years of experience building game engines, tools, and workflows. 4 of those years have been focused on machine learning specifically for game development. And in addition, I have about 2 years experience building animation and rigging software for DreamWorks Animation. And we won the SciTech Oscars for the software one of the pieces of software that I built. I've also been credited on 4 movies and 3 games. Let's talk about scope. Before we get into the talk, I just want to make sure that we make some ground rules out here. This talk is about artificial intelligence. Actually, it's not about artificial intelligence. Artificial intelligence tends to have this stigma associated with it. It almost sounds like there is this entity that is coming to take over your jobs or your tasks, or like that's coming to take over control from us. That's not what we want. What we want is something that can assist us to doing things better. So I like to refer to this as assisted intelligence. We want this. In this form, machine learning helps us in doing what we want to do, but better. It's not replacing us. It's just making us better at what we're already good at. This talk is about creative agency, about how you can release control to get more control, release creativity to get more creative in whatever you want to do in making a game. This talk is about raising the floor of creativity, not just raising the bar. We'll talk more about this, but the essence of this is what machine learning, understanding fundamentally what machine learning is good at and what it doesn't do very well. What this talk is not about. This is not a sponsored talk. I'm not representing any company. I'm not representing Zoox, Unity, or any of the tools that I represent here, that I present here. I'm not advocating for one tool over the other or techniques over the other. This is not sponsored in any way. This is just me presenting to you about what I've learned. This is not a survey of the state of the art. New research pops up every day, and my mouse keeps going in the wrong screen. Yeah, this is not a survey of the state of the art. New research comes up every day, and keeping up with that research is hard. But what's harder is actually finding ways to productionize it and make it really relevant to the problem space that you're looking at. This, and more importantly, this is not a talk about the socio-ethical implications of machine learning. I believe that there is a time and a place to have that conversation, and it's a very important conversation to have. But this is not it. This talk is not speaking to that, on that front. So, trivia time. How many of you know what these two are? All right, so the one on the left is an Atari, and the one on the right is a Nintendo. I noticed a couple of hands out there, so I'm guessing you know what it is. But these are game consoles. These are retro game consoles. These existed in the 90s, and they were really popular then. They were great consoles of their time, and they had a ton of games and an even more passionate group of game developers. But what's unique about these consoles is they didn't use CDs. They instead used these cartridges, these tape-sized devices that they filled up with games, and you could plug those into your consoles and play them, kind of like the CDs that we had of the past. I say past because now everything's online. And an interesting thing happened. Once those cartridges came out, they also came out with multi-carts. Now, what are multi-carts? Multi-carts are actually cartridges that they have loaded with hundreds and thousands of games. And you can see an example of this. Like these two screens are from two different multi-carts. You see that there are 9 different variants of Tetris. There are like 4 different variants of Pac-Man, and on the other side you have like so many different versions of Galaxian or Super Mario. Some of them are legitimately new versions. Like there are actually different versions of Pac-Man and Miss Pac-Man, which deserve a place as a separate entry in these cartridges. But some of them were differing only in textures and reskins. Now, what are reskins? Reskins are technically the same game, but you take like these textures and repaint them, give them a different environment. So you take a lush forest, a game that's set in a lush forest, and then you repaint that to be in a desert or something. And that's like a reskin of that game. You're just taking the same game, making it look slightly different, or completely different, because this is art, right? And it's subjective. These textures will have to be hand painted. That's a time-consuming process, because now in addition to all of this time you spent trying to imagine these new worlds, you now need to sit down and actually craft those worlds in art. You need to create new environments. You need to create new worlds, and it's time-consuming. If you want to simplify this into a graph, and this is an extremely simplified version of the graph, what you're doing in this process is you're taking this art, which takes a lot of the time, and the experience, which hasn't changed much from the original game. You're not spending too much time in updating that. But what if you could do this? You could like shrink that time down completely for creating that art, and instead spend that time in improving the experience. Create a new controller scheme. Consoles have changed, generations have changed, you have different input schemes. You have VR, maybe you'll port this game to VR. And that's the essence of like these remakes. You're reimagining this in the modern time. You're not just changing textures, you're also changing where you play this game. And that's a very important change that you need to make to gather new audiences or to appeal to new generations. NVIDIA recognized this, and I think a couple of months ago they released this piece of software called RTX Remix. What RTX Remix does is it uses machine learning to take an old game, a retro game, and change textures, like up-res textures, give it higher resolution so they can fit in the memory budgets of these new high-powered consoles and PCs. You can dynamically edit meshes, you can upscale textures, you can create new variants using machine learning models, and all of those are the same reimaginings that you had, but you get the option of exploring something that is just not, it's not bound to your imagination, it's bound to the imagination of whatever data set was used to create that model, which could be anything in the world right now. So yeah, this is a very interesting piece of software. And it's open source. It should be. It's a great piece of software, and we want to make great games. So, yeah, leverage this. It's a really good place to start. And here's actually what it can do. You can see on the left is basically the original game, and on the right is the remixed version of this game. This took less than a week for people to make. I didn't do it, but this is NVIDIA, right? I mean, they've shown that it's possible. You can do this kind of work. It's definitely possible to. You can see the lighting has improved, the textures have been up-resed, and there's so much detail added to the world. The environment is so much more vibrant. But that's not exactly development, right? It's not game development, or is it? Now, if you want to simplify the whole flow of making a game, this is one of the more simplified versions of that diagram, but it covers the main concepts. Now, there's interdependence between each of those fields, but in essence, these are the different stages that you'll go through when you're making a game. And remixing, or the place that RTX Remix lives in, is here. It's in iteration. It's in creating new versions or reimagining the versions of the game. Like it's the life cycle, end of that life cycle. And it's definitely part of the game development process. So yeah, well, we're back to making games. So, machine learning. Now we come to the core of the talk. Machine learning is now being leveraged in all aspects of game development. Actually, most aspects. Some of the aspects don't make sense, and there's a reason for it. But let's look at some of them. Concept art, where the idea to come up with as many different unique ideas that can fuel your creative imagination. Like that, it's a great place. Like, you've seen Stability AI, you've seen Midjourney. They do this really well. This is taking like the general consensus of the internet and telling you what you can do with this data. NPCs, where machine learning is breathing life into characters of the game, giving them unique personalities and reacting differently to like a changing player style. So if a player plays differently with an AI, it's gonna, or with an agent in the game, they're going to react differently because they are no longer bound to the static rules that you gave it. Animation and motion capture. Now, this is very important because the realistic motion capture for how the musculature and the skin drives the movement of specific aspects of your agent, and how the agent looks and what they were thinking, all of that translates directly to how that agent moves in the world. And machine learning models can understand those relationships and build a more realistic, more plausible response to an agent moving around in the scene. Procedurally generated environments, No Man's Sky is one of the biggest examples here, but you can also take a step back and say, I want to populate the world with trees. What is the best way of putting trees in the world? Let me have a machine learning understand that. Gameplay and how these agents react to... so have you guys heard of the Nemesis system in Shadow of Mordor? Yeah, some of you have. So what that does is, like, when you're playing the game and you interact with an enemy, how you attack and how you approach that combat changes the enemy. So the next time you come back and attempt to engage with that same enemy, he will react differently. And that's because they have learned, it's not machine learning because it predates the machine learning wave, but there is an aspect of learning there. But think about that, but not just for combat, right? What if you transport that entire enemy into your world, where he sees you, he understands you, he knows your fears, he knows what triggers you. And yeah, dynamic lighting and shadows. Now, this is a tricky part. This is very tricky, actually, and it's being heavily researched right now, only because there's a lot of tiny details that we don't immediately notice in the world that provide useful signals to your mind about what's real and what's not. And a lot of these are missed if you don't pay attention to it. But machine learning models are trained to understand those nuances, those little details that make sense. So this branch of models, they attempt to take you out of reality into this game world that feels more real or as real as the real world. And this whole all of these models in general are trying to shrink the gap between what's different between real and simulated worlds. And the more we can do that, the more realistic your game feels. So yeah, but now we looked at these pieces in isolation, but can we now have a single model that just does everything? Can it create an entire game for you? Well, it's been tried. Like, a couple of developers have done this, and there was actually a talk or a workshop this morning. So if you haven't seen that, then reach out to the developers. But there was a workshop where they were making a game using AI tools, and it was good. But there are it's great, and it works for the most part. But as you can see from this image of solar system that GPT-3 created, it's great. It works, right? That's exactly how a solar system looks like. Um, but yeah, that's right now. It's not going to always work this way. Models are getting better. Machines are learning. They are going to have the ability to do things that it they have not been able to do. And one thing that they've not been able to do is now cohesively tie the different elements. For all the pieces that we just saw, how do you tie it together into one cohesive experience? It'll happen. It's just not gotten there yet. Let's reason about the why, right? We want to understand why that's the case. Why does it not work? And to do that, we got to go back to a very old paper called, this is, how many of you know about what this is called? This is the Pareto optimum. I think this was in the 1950s that came out. And usually it goes with the commonly heard phrases, 80% of the work takes 20% of the time, and conversely, 20% of the work takes 80% of the time. Now, if we can take that 80% of the work, which is generally the ideation and all the recreative work, if we can take that and use machine learning to shrink that, then we can focus on the 20%, which is the creative part. That's what makes your game unique. That's what makes it stand out. Well, how do we do that in games? Development of a game goes through multiple phases. And one of the phases is like when you go to concept and when you're trying to build, when you're coming up with new ideas for what your game should be. You need to go out there and source. And this is where the art Bible comes in. And you're looking for sources of inspiration. And you're trying to find where these pieces of, where can you take this game? How can you make this the vision that you want to do? But you want ideas to do that. So that's where the divergence comes in. Like you're diverting out into the world to source new ideas. You take all those ideas and then try to boil it down to one that makes the most sense or aligns the most with what kind of game you want to make. That's the convergence. And then there are multiple cycles of this that happens, like even in engineering you do this. You're like, I want to create a realistic movement script. And there are different ways to solve that. Now you go diverging, you look out for like what are the best ways to do this. You read papers, you look at code, other people, and you go to talks. Right? You understand what the state of the art is, and then you come up with a solution that adapts to your game, very specifically to what you want. That's the convergence part. So every game cycle goes through all of this, and it traverses beyond just design, it's engineering as well. So we need a new flow for this divergence convergence thing. We need a new way to understand this and to incorporate AI into all of these tasks that we're talking for game development. We need a way to leverage AI to create more choices, and that's where like DALL-E comes in, or stability AI comes in. You're going and telling it, I have an idea. You put it into words and you describe what you want. And it gives you choices. It gives you different ways to look at that problem. And then you take all those things and you boil it, you take a couple of those solutions, or you mishmash one of those solutions, and you come up with one idea that makes most sense for you. That's entirely you. And that's the human aspect of this. And we shouldn't have machine learning do that for you because it's not good at that. It doesn't know what you want exactly, right? So yeah, let's focus on, let's put all our focus into this top 20% and let machine learning do the rest of the 80%. Or maybe even 75 if you don't want to go with all 80%. Now, if you want to embrace this divergence, we want to have machine learning tools to do it. There are different tools out there. For 2D, you have Leonardo, Night Cafe, you have Stability AI, DALL-E, Midjourney, Hotbot, Layer. You have so many different tools out there. You can go in and source ideas from here. You can give it a prompt and it'll give you 2 or 4 or as many as you ask it. Like as long as you have the credits with some of these things, you can generate ideas, right? They're going to take money for it, but it's giving you ideas, right? It's a model. It's a machine learning model that has understood the general consensus of what these images should look like. For animation, this is a tool called Cascadeur. And what it does is it allows you to do automatic keyframing and automatic skinned manipulations. And in this case, you can see, like in the left, if you, or actually, as you're moving the control point on the foot, the back, the spine is moving as well. And that's an interesting concept because in traditional skinning and animation, you would have to manually move things around, or you would have to set up these weights that translate to this movement. You don't have to, because this model understands what a human movement looks like. And then there's Unity, which has done a lot in putting together everything, all of these tools into a single umbrella. It's not there yet, but there are a lot of ideas out here that you can just use, right? I mean, from the style changes to texture changes, and none of these things are actually changing the texture on the hood. They're actually running machine learning models to change that for you. Like this rendering change, that's a machine learning model that is telling it, I want this in a desert, I want this in a rainforest, and you don't change the textures, you don't change the models, and it just does this for you. And there's a little more, like this is the more creative aspect of, like, I want to create a realistic mountain, but I don't want to edit every single crevasse, I don't want to edit every single piece. Can I have a model tell me what a realistic mountain looks like, right? And yeah, Unity has tools, or is planning on tools to do that. Reach out to the Unity team. They have a talk tomorrow, I think, so yeah, reach out to them. They're looking for beta testers for this tool, so yeah, please reach out to them. Okay, so yeah, you did all that, and you used all of the tools out there, and you're like, this isn't exactly what I want. I did everything, but this isn't the look I'm going for, or I want a very specific look. This is where and this is very common, because this is a point where you have, in the Pareto optimum, you have crossed that 80%. You have now reached that, because the 80% is what machine learning models gave you. They gave you the diverse options. Now you need to converge. You need to hit that top 20%. And this is where you need very specific control. And this is where you need to start training your own models. Training your own models. Now this is a very touchy topic, because you go on the internet and you look up, how do I train a model? And this is what you see. Like, you need to learn linear algebra, you need to know calculus, you need to have a deep understanding of Python and C++, and you need to know all the different machine learning techniques out there. Well, that's not exactly true, and I'll show you. Like, these two things are not required for you to get started. There's a place for them, but not for you to get started. Instead, what you do need is, you need domain specificity. You need to understand the specific requirements of the domain that you're trying to speed up. Like, if you're trying to speed up graphics, you need to know what makes good graphics. If you want to speed up level design, you need to know what good level design looks like. And you have this. Like, everyone in your studio has a very specific, unique skill, and they're good at that. They're great at that, right? I mean, if you are a graphics designer, your superpower is like creating compelling graphics. Like, how do I create realistic fire? How do I create realistic cloud simulation? If you're a designer, your superpower is like creating compelling progression and gameplay elements. And so everybody has something that they're good at, and so we should understand that, or we should go talk to them and figure out what that'll make sense. And of course, you still need to know a programming language, but you don't need to know everything about it. How do you get started? Now, there's a lot of resources on the internet that can help you get started. There's online courses, there's GitHub repositories, there's online communities that are focused on helping you make you get better. And the links to all of these will be provided in the slides, but what's most important here, and the one thing that I will ask you to focus on, is the last thing up there in the hands-on exercises. Start your own project. Do something. Pick up any topic that you're passionate about. Start something. It doesn't have to be unique. It doesn't have to be something that's not been done before. You just need to start something. And to show you how easy this is to get started, I'm going to take a little break here and show you a live demo, right? And it's running on my laptop, so we'll see. The internet is flaky out here, but as with any live demo, we'll see. Anything can happen, right? So I'm gonna try and move this window there. Okay. Now, so one of the websites I referenced in the talk was Hugging Face, and Hugging Face has a bunch of models that you can just pull. And what's interesting about all of these models, and specifically this one, you can look at, they have a GitHub repository that describes all the details about the model, if you're interested. It has instructions on how to get started with that, how do you install a local version of that model, and it has sample code. How do you use this repository? And what's interesting, it's not 100 lines of code, it's not even 50. This is it. This is all the code is. So let's see what this code can do. And for those of you, how many of you know Jupyter Notebook? Okay, so Jupyter Notebook is a way to run Python interactively. You can run it visually and see the output inline. So basically, I can run this out here and see the output show up right underneath it. So yeah, we'll see what happens. So I run this piece of code, and it's importing things, and now it's actually loading all the components from Hugging Face, and then it loads up this default image that is provided by the repository. This is the authors have provided this one texture, and now I want to turn him into a cyborg, right? So it's going to take some time to download the model, convert it into a form that can be executed on your specific machine, GPU, what it may be, and then it's running it. And you can see it's not minutes, it's not hours. This is 10 seconds, 14 seconds exactly, and there you have it. This is what the model thinks the original image will look like as a cyborg, right? And you can have fun with this. You can say, I want this to look like a werewolf, and 5 seconds later you have this scary looking werewolf. Now your game can be a werewolf game. It's done. And it doesn't have to be this image. You can take the images out of your game and push it through this model, and then you can have your character look like a werewolf. And that's the interesting bit. It's agnostic to where this data came from. And yeah, I was having fun. I was having so much fun with this, I started giving more prompts. Now you're building a zombie game. He's eating a head of a corpse, and you get this. It's great. Now I can put this as a wallpaper in one of the rooms of my game. Yeah, so yeah, let's try one more. Steampunk games. There you go. So you can do this. And how many lines of code was this? This was 50 lines. This is literally all it took for you to get this working with an image of your choice. Now, if you want to go deep, the authors have actually provided GitHub repositories that tell you how to train your own model, how to generate your own data set, so you can have your own model tuned to the very specific needs of your game. And you can do this. They have instructions on how to run it, how to train it, where is the data coming from. And if you don't want to do your own, and they have a fine-tuned GPT-3 version as well out here, so you can train this to your specific needs. So yeah, give this a shot. All right, back to the presentation. Goodbye, helpful window. All right, and so you've trained your own model, but now you want to optimize this. What can you do to optimize it? You want to make it faster. You want to understand how it works under the hood. most of the training, most of the machine learning models are trained using one or more of these frameworks. This is just a sampling of some of them. There's PyTorch, TensorFlow, Scikit-learn, Keras, and JAX. There's a lot more, but this is the most common ones. So you can spend time to understand what the strengths and weaknesses of each of these frameworks are that are used to train these models. It's not necessary, but you can do it if you want. It all depends on how deep you want to go in that chain. So remember those two things I told you are not important? They are important if you want to go back to one of these frameworks and optimize your model, optimize your code. But if you don't want to do that and you want to use off-the-shelf models, sure, it's 50 lines of code. Just do it. Yeah, but firstly and lastly and most importantly, start with domain specificity. Understand your problem, understand the needs of that space that you're looking at before you even think of machine learning models. So remember those reskins that we were talking about? Well, as we saw right now, machine learning is great at that. This is DALL-E. This was 5 seconds. So let's make great experiences and let machine learning do the rest. Thank you. I have all the references here, so it will be shared with you. Okay. If anyone has any questions. I don't know if you guys could tell, but this is my first GDC presentation, so I'm shaking right now. So thank you. You guys have been a great audience.
So how can you run these models on your laptops with having low computes, low cores and low GPUs?
Okay. So the question is like, how do we run these models on restrictive devices like laptops or phones or something? There are, so there's a difference between training the models and running them. Are you looking at how do you train them?
Train the model.
Or train them. So yes, that is a challenge. If you want to train them, you need to have uh, a device that is capable of loading all that data and having those uh, steps that it would take to train the model. So you would either need to tweak your model to be smaller so it fits in your on your laptop or whatever device you're running on, desktop or whatever device you're training on. But once you train a model, the output of that will be can be really tiny. Depends on how you set up that model. Like this model was a couple of megabytes. You can easily load that up on any device.
Thank you.
Oh. If you have a commanding voice, you can just ask me and I'll repeat the question. I didn't catch what you're researching on. Sorry. Like you said
So,
you were researching. Go ahead.
yeah, so I've been trying to research on generative AI NPCs for so long now, and I don't know where to start with training my agents. Okay, first thing is that. Second thing is I want to create the agents which are personalized personalized to your user. Like, if you are having a doctor in the game or having a merchant, so they should know what your character is doing all around. Like if you go to a shop, you tell them your query, you tell them about your personalized. So same way how a character is gonna be. So understanding that situation or understanding that model, it's gonna be hard to train, right?
Right.
And my question is to you is how and where to start in such scenario in training that model.
So your question, I'm just going to repeat this question just so I make sure I understand what you're asking. You have a very specific need for this generative AI model, and that of like I want to have the conversational agent with specific to say healthcare or a person in my. I'm sorry, I think I got it wrong then.
Agent who's a generative AI or NPC. Okay.
Okay.
So not just an agent, like more like a NPC that that plays around with you as a player, but being an
Oh,
NPC.
okay. Okay, so like a companion
Like
that.
not even companion. Like he's in a game. Like let's just say you are NPC to my life, right?
Okay.
Like let's just say I'm the character, I'm the player, and
Uh-huh.
everybody around in this hall is an NPC, but they all have their own personality. But
Okay.
they have the personality that's been designed and directed by the designer or an artist or based on the storyline.
Got
But
it.
what if the character has their own personality they come up with? More of a, it's going in the way of being a sentient, but yeah.
Got it. Okay. Yeah. So you're asking how do you personalize these models to be more specific to your game and your experiences.
More like having a model that understands its own functionality. Like let's just say I have a doctor who is in the medieval age, so he knows he's a doctor in the medieval age. So he should act like a character who is in medieval age as a doctor when a character comes in, like I have
Okay.
hurt my knees and I have done
Okay.
this,
So
something of that sort.
yeah. So what's important to think about there is there are two different levels of that same problem. You have a general human behavior, which is like how would a human react to, like, I walk up to someone and punch them, right? How would they react to that? That doesn't change depending on whether you're a doctor or you're a soldier, right? It doesn't change. They are going to react. They're going to like respond to it. Either it's going to be a fight or a flight. That's a that's a general reaction to your action. But then you have specificity saying if someone injured comes to a soldier or comes to a doctor, the reaction is going to be different, right? And that's where you can split your model into two. You can have a single model which tells you how does a human react, right? And then you can fine tune that model based on the different personas that you have in your game. Now, how do you actually go about this? You get a lot of these models that are general human behavior available on the internet. Like GPT is an example of that. It's a conversational bot that can talk to you about as a general human. It's not specific. It can't answer. Like if you tell it, I have pain in my right shoulder, it can't tell you what to do with that. Like, or maybe it'll tell you, but it's just like I don't know. I have no confidence in this is good or not. So you can take that general purpose model and then fine tune it on a very specific set of doctor responses. And then you get this model that is very specifically a doctor, but also has all the traits of your original human.
Hello. Hey, thanks a lot for the great presentation. So yeah, I get why GPT would be like a good use when you want to generate something new. But we also got to be careful about the data which is actually being used to train the model, right? So I think GPT does use a lot of copyrighted content as well. So I think it's a great huge debate online as to is it even possible to go back to the actual image on which the generated image is created from. So shouldn't we be extra cautious about the generated image, and if we are encroaching into the copyrighted territory, how do we ensure we stay away from that?
You bring up a very important point, and you're absolutely right. You should know where that data comes from. You should know how that data was sourced. Is it ethical or not? Like, have the authors been credited for that information? And the debate that's being had online, the one that you're referencing, is a very valid point of conversation. It's a conversation that needs to be had. And there are efforts to actually go about retracing the steps of this model to understand where it came from. I think there's a website called perplexity.ai, where the perplexity models actually reference sources of where it got the information from. So I would recommend looking at those if you're really concerned about where that data came from. But if you want to use ChatGPT or you want to use the Stable Diffusion, use it by all means, but don't use it in your final product until we understand what the ethical implications are.
Hello,
Hi.
myself Nipun. So we work with synthetic data. So
Yes.
we use Unity and Unreal to train, like create synthetic data and train machines. And we wanted to mix synthetic data with Gen AI to create that realism. How do you see that going forward using synthetic data and Gen AI
So using synthetic,
combine together training machines to achieve it?
so you're asking what I think will be the future of using synthetic data in games?
Yes, with the combination of Gen AI to enhance the realism and
I'm not sure I get the difference between synthetic data and your Gen AI.
so consider realism. So we create synthetic data which is not super realistic when you compare to, like, consider I'm from like automotive domain. So we want to train machine learning models with synthetic data and create
Got it.
simulations,
Got
and
it.
which is not close to real.
Yeah.
Yeah.
No, that's a very good point you brought up because any data that is sourced, whether it's sourced from the internet or it is synthetic in nature, it comes with inherent biases. There are certain things that you just don't think of, right? It's one of those things that it's hard for a human to discern whether the data is complete or free of bias, right? And Gen AI doesn't actually help with that either, right? It still has its own biases. So I don't think it's going to help in the sense that it's going to help you get away from those biases. Understanding those biases is the first step. Like, what is the synthetic data that you're getting? What is the source? And what are the biases? Now, the biases, understanding what the biases are takes a lot of work. But it's an important step, right? Because that's where your model gets biased, right? So I have not seen much work done in the front of understanding. Actually, I take that back. There is a lot of work done in understanding biases, but implementing them in practical models like GPT and like stable diffusion. It takes time. It's not something that you can just say, oh, I have this algorithm. And that's where the whole point of research comes in, right? You do research, but productionizing research is a whole different ballgame. It takes time to understand, how do I take this research about understanding biases and productionize it? How do I put this into the model?
Yeah, that's what we are trying to do. We're trying to research, use synthetic data with the combination of Gen AI to push this forward.
And that's great. I wholly appreciate what you're doing.
Can you please share the references which you shared again so we can
I
just
think the
take a small.
slides will be completely shared, so you should get all the references from there.
Thanks.
All right, well, I think we have time for one more.
Hello? How can we reduce the processing time? So when you are integrating the backend, so
Right. The question was like, how do we reduce the processing time for training these models or running inference or those kind of things? It's not easily, and that's where your knowledge of like the mathematical backgrounds, the machine learning techniques, all that comes in. Like if you want to go to optimization and you want to go to the specifics of how this is implemented, how it runs on device, you need to know the language. You need to know the machine learning, underlying machine learning models that are used. and you need to know the numerical background of how this thing runs on the device. You can't optimize it generally. You need to look at specific components and change those. Like you can do things like, there are different techniques that you can use. Like you can change how much bit width it uses, each model. You can change it from like 8-bit to 16-bit, or 16-bit to 8-bit, and then you use less memory, but not the same, not really much less computing, right? You can improve on matrix multiplications, or you can completely change the model architecture. But there's no one solution. You can't, there's no one solution to just, this will make it faster.
Hello. I had one question.
Sure. I don't know if you have time, I think. All right, we'll take one more.
Sure. So my friend here just
Music. Oh,
okay. No problem. Just before uh, my friend asked one question about training through synthetic images and then using the camera to figure out the things in real life.
okay.
So that is something we are trying to do, and like creating artificial images which look exactly real
Okay.
through realistic rendering softwares.
Okay.
So even after using all those applications and all those things, even after training, the accuracy is not that great compared to real world images. And like changing the backgrounds, changing the image quality, the different type of pixels we are also like pixel size. Like 224 and 224 is the market standard for most of the trained models we have seen. But we are not differentiating between an apple and a banana. We're differentiating between uh,
A
a
car and a bus.
Chinese apple or a Asian apple or a
Oh, okay.
Kashmiri apple.
Got it.
So that is a level of differentiation we need to do. So
Okay.
what do you suggest going in the direction? Like how can we do this level of differentiation using training models? Do you think
That's an interesting problem to ask, because it almost reaches the level of, I need to have complete understanding of what this scene looks like. And if you want to encode that, then your model is going to have the capacity to learn that information, right? Like, what is the actual difference between a Chinese apple and a Kashmiri apple? It needs to learn that difference, right? There's like striations that are different in these apples. There are color differences that in these apples. It needs to encode all of those differences into the model, which means either your model needs to get more complicated or larger. It needs to work in a larger space, or it just needs more layers to understand the relationships.
so?
But I can't tell you what solution will work here, because that's where the whole exploration of which model fits this data best works.
Exactly. So, which model works the best for such type of products? I haven't seen any kind of thing, like most of the times it's a differentiation between a chair and a table.
That's correct, yeah, you're right. I mean, the production models are general purpose. They're not meant to be this specific. Yeah, so I can talk to you outside if you want, but
Totally
yeah,
fine,
I think
totally fine.
the
Sure.
point is that you want to have your own model to do this.
Yes. Thank you.